All right, we should be good. Hello, everyone, and welcome to this Friday tutorial. Thank you all for being here. We are going to basically do a very introductory tutorial to Unity. So this is pretty much, you've never touched Unity, and we are going to try to build a very simple game. So, what have I done here? I have just created an empty project. I've used the 3D template, and this is what you should be seeing when you create a new empty 3D project in Unity. Now, we are going to just take a look at the UI very quickly. So you'll notice we have basically about four different sections in this default layout of our windows here. First, we have the hierarchy window up here in the upper left corner of the screen. This is a description of all of our scenes, all of the game objects in our scenes. Game objects are the base units of things that go inside of games. They are objects on which we can write scripts, attach components, do all of the basic things that Unity is there for. So we have our sample scene here, and you can notice that we have only two game objects currently in our sample scene. We have a main camera, and we have a directional light. Cool. Given that we have our inspector window changing as we click on these different game objects, let's take a look at the inspector window. So, when I select a game object, the inspector window will update to show the properties of this particular game object. It has things like the name of the game object in this field here. It has whether or not we can see, or whether or not the game object is active currently in the scene. And if we disable our main camera by clicking this little box, you'll notice that we have no rendering happening because we have no camera. We have other things like tags for game objects, which may be very useful if you want to very quickly categorize game objects and find them in a quick way. So we have tags for, say, the camera. We have a tag for the player, perhaps. You can also set up custom tags, like clicking the Add Tag button, adding something to this list, writing out whatever your new tag may be. Maybe it's something like enemies, collectibles, power-ups, things like that. And you can save that and add it. All right. We also have layers, which are useful, particularly in 2D games where you have multiple layers on which you want to show various tile maps or various layers of tile maps. This becomes useful when you want to do things like parallax scrolling for your environments, And also we have things like raycasts, UI layer. All of these are very relevant for 3D as well. And we have a transform. Every game object has a position in real space. Well, engine space. And that is its transform. It has its position in X, rotation, and its scale. And then we have the various components that are part of this game object. You can see that this main camera game object has a component called camera. And this camera is an actual script. It's part of the Unity core scripts. This is a camera with the following fields. It has clear flags, background, culling mask, projection, FOV, and so on and so forth. And it also has a audio listener component. So those are the various components. Whenever we want to attach a component to a game object, we can do that, and it will show up in this list. And we'll go into that a little bit more soon. That's the inspector window in a nutshell. There's a lot there, but that's the basic understanding. All right, let's move on to the project window. Down here, in our lower half of the screen, we have our project window, and it's here that you can see the entire hierarchy of the project. So every Unity project, its root will hold the assets folder. And part of the assets will be a scenes folder. And you can see here we have our sample scene. Now we can rename this scene to be anything we want, and we can do that. We can right-click it, we can rename it, we can call it demo. And you can see that it was updated. The name changed here in our hierarchy window, and you'll see it has a star. If it has a star, that means it hasn't been saved. So we need to save it. And the keyboard command for that is Control-S, as it is with lots of other things. That's the scenes folder. Now, as you create large projects, you will want to make sure that you are very, very organized. You can find things when you need it. So we'll want to, as we go through this little game that we're about to make, we want to make sure that we are creating folders and organizing things in a reasonable way. So for instance, I might, on creation of a new project, add the following folders to my project, just so that I have them. We can right-click in our assets folder here. We can create a new folder, and it gets created right here. We see this new folder. We can rename it. Let's call it scripts, so that we always have a folder containing all of our C# scripts that we might want to add to our game objects. And let's create a new folder. And let's call this one prefabs. Prefabs, we'll get to those. They are game objects. They are prefabricated game objects. And we can create those in our hierarchy and drag them to the folder so that we can reuse them anywhere we want them. And these become particularly useful when we are doing things like spawning game objects into a scene. All right. We also have our final window right here in the middle of our editor here. We have our scene view. We have nothing currently in our scene view. We can navigate the scene view using the keyboard commands. You can use WASD and right-click. If you right-click, you can change your perspective. And if you hold right-click and use WASD, you can zoom in, zoom out, fly through the scene as if you were a camera, which is very, very cool. Also, as part of the scene view here, we have our game view. And this is what is shown when the game is rendered, as it is. We have right now, I have selected the 1920 by 1080 aspect ratio. So this is what our game would look like if it was fully rendered in 1920 by 1080p. And that's a reference that I generally use. You can set it to any ratio you want. If you set it to free aspect, that means that it will scale to whatever ratio that you set it. If we were to pull out this window, for example, and resize it, then it would be whatever that resolution would be. So that's a question I get a lot. What is free aspect? What might we use it for? If you want to just mess around in various aspect ratios, then free aspect might be for you. But I generally use a 1920 by 1080p ratio when I am building for desktop applications, Windows, Mac, whatever it might be. One final one that I glossed over, the console. We have some stuff here already. This is where all of your debug messages might be written. You can write it to the console, and this is where we can see them. We have a few errors. I'm not sure why these happened on project creation, but we can clear these, and if we press play, they shouldn't occur anymore. Let's see. Yeah, okay, so all good. It was just a strange thing that happened on project creation, memory allocation. Sometimes it's a little weird. You'll notice I just pressed play. When we press play, we go into our game. Our game effectively starts. We can press play. This will show us our game view. And we can also press pause, And this becomes useful when you want to debug at a certain point in your game. We can also switch to scene view in the middle of play, and we can see things happen from any angle that we want. Okay. Those are our 4 main UI windows. Let me hop over to Discord, see if there's any chats going on. Are there any questions so far? If you have any, you can drop them in the chat. I'll try to read them. If you have any, you can come up, speak on stage if you'd like. Any questions so far? Cool. All right. I'll try and keep an eye on chat. All right, let's make something now. Let's do some game creation. This is my favorite part. All right, so we have our scene here. You'll want to create game objects as you build your games. And the easiest way to do that, we can right-click in our hierarchy window here, and we can create various things. You'll note if you want to get a very, very easy way to get primitive shapes, you can do that by going to 3D Object. They have cubes, spheres, capsules, cylinders, planes, quads, and a bunch of other stuff. Text, ragdoll, terrain, tree, wind zone. I haven't even taken a look at wind zone, but I imagine it's pretty cool. You can also create effects like particle systems, lighting systems, audio, video, UI. But for today, we're going to be taking a look at our primitive 3D objects here. And let's create a sphere. Let's create a sphere. And let's put it in our scene. There it is. We have our sphere. I generally, when I am building something from scratch, I like to zero things out. So I go to the transform of the sphere, and I make sure that it's at 0, 0, 0. And whenever we want to focus on our sphere again, we can just double-click it, and we'll go back to it. And let's take a look. That's what it looks like in our game view. If the game was fully rendered, this is what it would look like. Now we can change this. We're a little zoomed out. We can go to our main camera, and we can open up our camera component here, and we can, say, decrease our field of view. This will zoom us in a little bit. Yeah, something like 30. Maybe, yeah, 33. 33 is good. All right, so we've created a sphere. You'll note that this sphere, on creation, has a bunch of things already. It's obviously got a transform. Every game object has to have a transform. And it also has a mesh renderer. So it has the mesh of a sphere and a mesh filter. And this is the actual thing that gives this its rendering capability. Our sphere mesh here. It also has a collider. And colliders will become important. These are, if I disabled, for example, our mesh renderer here, all that's left is our sphere collider. So this thing has no physical representation anymore. It's just its boundaries. Its collider. We turn it back on. It has its physical representation again. All right, so we've created a sphere. What are we going to do with it? Well, we can rename it, and this is what I intend to create during this tutorial. We want to create a simple game where we have a ball, let's say, and this sphere is going to be our ball, and we would like to launch our ball upwards. We want to launch our ball upwards, and we want to dodge, let's say, moving blockers that sit above our ball. And if we can get it past the blockers and into our goal zone, then we want to increment our score, so we want to keep track of things like a score, and we want to display that score to the player. That's the goal of this tutorial. So, let's try and do that. So, we've created our ball. We're going to call this ball. Now, what else do we need? Well, we want our ball to be able to be launched. So we need to give it some sort of physics. And we can do that very simply by adding something called a rigid body component. Now we can do that by clicking on our ball, going to Add Component, and we can search for, let's say, rigid body. And we can add this component to it. Make sure that when you're working in 3D, so spheres, cubes, all that stuff, you're giving it a 3D rigid body, which is just the rigid body component. Any sprite work that you do, let's say in 2D games, that would need to be given a rigid body 2D component instead. But for 3D objects, we just want the normal rigid body. Once we give it a rigid body, it has physics. So if we play our game, and everything compiles very, very quickly, you can see the ball drops. Gravity is acting upon it. It has a rigid body. Unity knows to start the physics engine. It's got gravity. It falls. Okay, so we need a way to stop our ball, obviously, so that it doesn't fall into infinity. So we're going to do that. How can we do that very easily? Well, we can create a new 3D object. Let's create a cube this time. And let's call this cube ground. Again, I like to zero things out, just so that they are all in a relative place to each other. And I'm going to place this maybe at y minus 1. So it sits below the ball. I want its y scale to be, let's say, 0.1. So it's thin, and we can see it. We zoom out a little bit. Sitting below our ball, this is what we can see in our game view. And let's say I want its x scale to be 5 and its c scale to be 5. So it's a fairly large platform on which our ball can sit. Okay, so we have a ball, we have a ground. Let's press play. And there we go. Our ball falls. It sits on our plane, or rather our cube, and there it will sit until we interact with it. Okay. So the next goal that we had set for ourselves, we want to be able to launch the ball, right? Let's do that. How are we going to launch the ball? Well, through scripting. We can add a script. So, what I like to do whenever I'm about to add a script to a game object, I like to go to my scripts folder. I'm going to right-click. I'm going to hit the Create button, and I'm going to select C# script. And this I'm going to name ball. Ball.cs. This gets created. Now, we have to attach this script to our game object. Don't forget this step. This is very important. Let it do its thing. Let all of it compile. Good. All right. And now we're going to select this script and drag it right onto our ball. And when we click on our ball, now we should see a new component that just got added. Our ball script. We can double-click the ball script here, and this will open whatever editor that you are interested in using. If you have the Visual Studio Community Edition for Unity, that I think should already be set up for use in Unity. So if you double-click scripts within the editor, it should correctly open up. If you are using Visual Studio Code, like I am, then additional steps have to be taken. You'll have to go to the settings in Unity. So if we go to File, Edit, Preferences, External Tools, and we want to select Visual Studio Code, and there we go. That will enable Visual Studio Code. When you double-click on scripts in Unity, it will open up. All right. So we have this script. Let me close it out. Let me make sure first that OBS is getting the script. No, it's not. All right, let me fix that real quick. Add a new window capture. This will be script. Okay. Good. All right. Okay. Hide that for a moment. All right. Great. Let me share. I am just going to share my display. Change windows. All right. There we go. Now you should be seeing everything that I'm seeing. You should be seeing the script window. OBS should be recording the script window. Excellent. All right. So we have our ball script here. You can see on the the left-hand side, Visual Studio Code gives you all your scripts, your hierarchy of your project here. You'll note that we have this class called ball, and ball is derived from MonoBehavior, and MonoBehavior is the root script, the root class from which all game objects are born. You'll note, again, as Professor McCoy pointed out in class the other day, this particular MonoBehavior word contains you, because this is a very European European product. So we want to launch our ball. The way that we can do this is by directly referencing our rigid body. Now, how do we do that? Well, first, we actually need a reference to the rigid body. And we can do this in a number of ways. We first have to declare it as a variable. And the way that I like to declare variables in Unity is to first make this a serialized field. Private. This is going to be of type rigid body and rigid body. We want to make things private. We don't really want other scripts to modify the rigid body on this ball. We don't want a random script to be able to change the rigid body. We always want the rigid body to be the rigid body that we assign it. But how do we do that if it's private? Because if it's private, by default, it will not show up in the inspector. So we need to serialize that field. If we serialize it, it will show up in the inspector. So let's take a look. We've just serialized this rigid body field. I'm going to save the script. We are going to switch over to Unity in just a moment. Let me bring that up. And we have our ball here, and you'll note in the our script, we have a new field. It's called rigid body, well, RB, and we are going to assign it this ball's rigid body. And we can do that by dragging our ball and bringing it over to this field. And once we place it here, it grabs the right component. It grabs the rigid body component that is attached to this ball. Okay, cool. Now what? We can go back to our scripting. And we want to be able to manipulate this rigid body, right? We want to apply some force. We want to apply some force only, let's say, when we click the spacebar. So we can do that. We can say if input dot get key down key code dot space, there it is. This is a shorthand for getting input. So we want to detect when the space key is pressed. So if the space key is pressed, what do we want to do? We want to apply some force to our rigid body. And the way that we can do that is rb.velocity plus equals, let's say, vector 3 dot up. Excellent. All right. Oh no, the screen isn't showing in the stage. Hello. Hi. The screen isn't showing in the stage. Was it... I've shipped it over to my Visual Studio Code. Can that be seen?
Yeah, can you hear me, Kyle?
Yes. Hi, Josh.
Sorry, my voice is a little rough.
No, no worries, no worries.
So how you typically solve this is you put OBS into a projector window,
Ah, okay.
and then you stream that with Discord.
I see, I see. That makes sense. Okay. Cool. All right.
And I'm happy to help you do that, walk you through that if you need.
Cool. Let me see. I will stop recording.
And I'll also make an announcement.